Okay, everyone, welcome to my YouTube channel and welcome to the Python programming language. Python is an interpreted programming language that it's easy to learn and it's easy to write code, but the concept of problem solving remains the same across various languages. Now, by interpreted, I mean you don't really need a particular software to help you convert your source code into a machine readable code. And by source code, I mean the code you are typing in to your source file, as in the ones that are English in nature, for you to actually understand. Let us look at exactly what I mean. Okay, Vim now. Vim now I'm currently working on a Linux box now. This is a Linux machine, Ubuntu precisely, and Vim is a text editor. You can use whichever text editor you feel comfortable with. Yeah, we have VS Code, we have Emacs. Okay, Emacs is still Linux based. Now we have Notepad++, which is actually on the Windows machine and all that. Yeah, so you can use whichever one, whether it's Nano or whatever one at all, or Gedit. So but as for me, I find it much more comfortable using the Vim text editor. So we're going to write a simple Python code so that you can see how an interpreted language works. Then we're going to write a very short C++ code so you can see how a compiled language works, because languages are either interpreted or compiled. So I'm going to call this one, let's say hello.py. Okay, I already have something here, hello.py, right, which is print hello world. Okay, I think I should have some files in there. Okay, already have some files in there, which is hello.cpp and hello.py. Okay, let's see what is inside our hello.cpp. Okay, this is the code inside. Okay, it's a simple code to actually print out the word, the statements now, hello world. Okay, let's assume now we've written this particular file, hello.py. We've written it, and after writing it, the next thing you're going to do is to just call your Python interpreter now, Python 3 hello.py. Now I'm using Python 3 here. I'm writing this 3 because the version of my Python software I'm currently using is version 3. So this particular Python 3 you are seeing is the interpreter, is the Python engine that is a command that actually activates the Python engine so that it can interpret whatever code that I have in here. But when I hit my enter key, you will see my hello world. It's as simple as that. So this is how an interpreted language works. At the same time, there is a particular interpreter, the Python interpreter, like a command terminal that you can actually write your Python code and you will get the results on the fly. But if I'm to check for my C++ code, the output of my C++ code, I will have to compile first, then I will now run it. Without compilation, it will not work. Now, for me to compile my C++ code, I will need a very tiny bit of software called a compiler. Yeah, and the name of my compiler that I'll be using is an open source one, which is G++. G++ hello.cpp. Now, if there's any error in my code, it will flag it out for me because it will not be able to compile. Now, the reason for the compilation, as I earlier said, is for the source code to be converted into a machine readable code. Now, that is a code that you cannot understand, but only the machine can understand. It's much more closer to the machine, and code written in compiled languages are a little bit more faster than the interpreted one. So, now I've done my compilation. Now, the fact that I returned back to my command line is an indication that everything went well. So, I will have to compile my code. Now, by default, when you compile a C or a C++ code, the output is normally a.out. That is what you are seeing here, a.out. That's the default output. So for me to run my code now, I'll have to say, okay, a.out, and that's it, hello world. Now, whatever thing I want to do, if I go back there now to edit it, okay, let's say we want to edit our Python code now, we'll have to go back there, hello.py, and let's say I want to print out something like programming is an intense fun. Okay, now after this I will save and exit. Okay, I'll save and edit and exited. Then let me run my code now. Python 3 hello.py, and it will run. So the last statement I wrote inside it actually works for me. But if I'm to do the same thing in my C++ code, I'll have to do something like vim hello.cpp. Then let's say programming is an intense fun, and I'll go like this. Then after adding that line, I've edited my code now. I cannot just go and just run it immediately to see my output. No, I'll have to compile first. After compilation, if there are any errors, the errors will be flagged during the process of compilation, and I'll have to go back there again to edit. Then I'll compile again. Then let's compile to see if everything worked out well. Oh, there's an error. Like I said, I have to go back there again to check it now to correct the error, and it's telling me that it's currently on line number 8 now. So okay, I misspelled that keyword. So let me go again. I'll compile, and hooray, nothing happened, meaning that everything went well. So I'll go ahead now to run my executable file now, which is a.out by default, and it goes programming is an intention, so it's already there. So meaning that you write, you compile, and you run. You write, you compile, and you run. That's how it is. If you have any error in your code, you have to go back there, you edit it, then you run. So that is how we work with compiled languages. But for Python, it's a straightforward thing. You don't have to compile. You just write and you run. You write, you run. You write, you run. So that is how it is. So on this particular channel, the version of Python that is used is 3.12 or 3.10, whichever one. Now, whichever one you're going to use, I think as at the making of this video, the current version I think is 3.13 or so. Yeah. Now, whichever one you're going to use, so long as you are using something above 3.0 and above, it is better. Now, if you are using 2.x now, as in 2.0, say 2.0, 2.8, 2.9, whichever one, you can still get the results that I am getting. But the problem is that there will be some little discrepancies between your syntaxes and my syntaxes, and it can result to you getting an error. And so you might not really get the results that I am getting. Now, a typical example is this. In Python 2, if I'm to write something like this now, if I'm to write my print statement in Python 2, I don't have to put my parentheses. Yeah. So this is a typical example. I don't have to put my parentheses. It works like this is how it is without it. So this is how it is. Print, then your double quotes and the statement that you want to print out. That's how it is. That's in Python 2. So if you're using Python 2.x, whatever, and you decide to run this particular print statement, you're going to get an error, because before because this particular concept of using parentheses in your print statement, that concept was included in Python after Python 2. So Python 2 do not have the knowledge of this particular pattern of writing this code line. So that is a typical example. That is why you just have to use something like 3.x and above, 3.0 and above. Then to download Python, you go straight into this. For Windows, you download the software and you can easily run the executable. Then for Linux, for Linux, as in Linux that are Debian based distros like Ubuntu, Linux Mint, and all that. Yeah, you have to issue this command. First of all, or you have to update your software repositories, update the links to see if there are any changes in the server lists of downloading software and all that. Then next, you update whatever software you have. Probably there are some dependencies that Python depends on for it to actually work well. You upgrade it and all that. Then before you issue the core command to install Python 3. And when you're installing Python, make sure that you have 3 in front of it, so as you will be very rest assured that you're actually installing the version 3 of Python. Then if you are using the Mac OS, then you have to install Homebrew first of all. After your Homebrew, then you can use the Brew package manager to actually install Python. And you don't have to write 3 there, because this one actually install the latest version of Python software in your machine. So the coding software that we're going to be using is predominantly PyCharm. Yeah, that's what I'm going to be using in this particular scenario, PyCharm. Now you can use whichever one you are much more comfortable with. The thing about PyCharm is that if you're developing a web application or probably writing an automation script, or you're doing web scraping and all that, I think it's from my own point of view, I feel it's much more comfortable using PyCharm because it's an integrated device environment where a lot of things are included for you to actually work with. And some of the brilliant folks at JetBrains. Now, JetBrains is the name of the company that are actually doing this particular PyCharm, that developed it. So some of those brilliant guys over there, they actually, out of their kind-heartedness, they gave us the community version so that we can practice and learn whatever thing we want to learn. So you can go ahead to this particular URL to download the community version of this particular PyCharm. Now, to take a view of it, you can see. Now, this is how it is. So the PyCharm. So, but before you download the PyCharm, you have to make sure that you have downloaded your Python and install it, because PyCharm does not come along with a particular Python interpreter. So when you install your PyCharm, you have to make sure that you configure it so that it can be pointing to a particular interpreter, so that it is that interpreter to use in running your code. It is that particular interpreter. And if you look at my environment here, below this particular point, you can see it's showing current interpreter, which is Python 3.12. So that's the interpreter I configured this project to use. Every project usually can be configured with a particular Python interpreter. So, and when you are using an IDE, have it in mind that you will have to be creating projects, because whether it's PyCharm or you're using other form of IDEs work with projects. So every little file that you want to create demands you to create a particular project. The name of the project that I have created here is tutorials. So that's it. And how do you create a file when you are using PyCharm? You just have to right click on your project name, go to new, then go to Python file. Then you can do something like you cannot write the name of the Python file without writing a .py. So let's say I want to create a file called test file. Now I can say test_file without writing a .py. You don't have to write a .py. PyCharm knows that you are creating a Python file, and so it will actually help you to put the .py there. So after that, you click on your Python file, you hit your enter key, and you get your, look at it, test_file.py. So it's already there. It is within this environment that you can actually type in your code and run it. Now, if you don't have an interpreter already configured in your PyCharm, it will definitely pop out some errors for you and all that. To do that, you can click on this particular menu icon there, and you go to your settings. Then under your project now, under this particular project now, the name of the project, you go to Python interpreter. Then Python interpreter, you can add a new interpreter. Currently I'm using this Python 3.12, and it is currently located within my user localhost being directory. If you want to add more version of Python interpreter, you have to come here, click interpreter, then add local interpreter. Then the dialog box comes out for you to actually search for a location where it's been located, where you actually installed it. And that is how you can actually add an interpreter after installing Python in your machine. So that's it for that. So if you are not really comfortable using PyCharm, if you are much more comfortable using Jupyter Notebook, no problem. You can go ahead to download Jupyter Notebook. Now, Jupyter Notebook can be installed in your system in two ways. You can either install Jupyter Notebook as a standalone software, and that's exactly what I did here. Yeah, this is the Jupyter Notebook environment. Now, you can actually install it as a standalone software, or you can install it alongside Anaconda. Now, Anaconda is a software that we normally use for things like data analysis. Data scientists use the same thing. People building AI models and all that use Anaconda. Now, Anaconda is an all-in-one software. It has this PyCharm that I've earlier explained. Yeah, built into it. It has Jupyter Notebook. It has your IPython terminal. A lot of things are embedded into it. Now, when you're installing the Anaconda, you have to go for the community version again, not the professional version, unless maybe you have some cash to actually fork out to buy this software. Now, for the Jupyter Notebook, this is how it looks like. This is how it looks like. When you launch your Jupyter Notebook, actually you get to see this environment. So to create a new file, you just come to this place, click on new, click on Jupyter Notebook, and you wait for it to load. Okay, yeah, it's done. Then it will ask you to select a particular kernel. By default, you have to select the Python 3 IPython kernel. Select, and that's it. So this is how the Jupyter Notebook looks like. How do you run your code in your Jupyter Notebook? It's quite simple. You can just type, let's say I want to run a single line of code. Print welcome to NLS Tech, for example. Now, okay, and after doing that, you just come here to click your run button. In that, so Jupyter Notebook has different types of mode. Currently, we are in the code mode, and it has three types: the code, the markdown, and the raw. Now, if you are on markdown and you're trying to write your code to run, after writing the code, you cannot be able to run it because you are not currently on the code mode. So make sure that you're always on code before writing any code and run it. And when you write a code, you get the result instantly. This is your result output. And all that. It has so many commands and so many things that you can actually do here. Now, whenever you run a particular command, it automatically brings out another new cell for you to use and run your code. So that is how it is. Then, let me go back to my PyCharm now. Now, this is the PyCharm. How do I run a code on PyCharm? It is quite very simple. It's similar to your Jupyter Notebook. The problem is the only difference is that it has a different output environment. If I want to run the same exact program I ran in that Jupyter Notebook by saying print welcome to NLS Tech. Now, how do I run this particular file? Let's go back now. Okay, the same run button you are seeing here is the same run button that is here. Now, but just a note of caution, make sure that this place is showing current file. The reason is because sometimes when you are working on multiple files and this place might be showing some other files, and you'll be working on another file. When you click on run, it is the name of the file that is here that will be run, not the one that is here. So make sure that you're always on current file, so that whenever you hit your run button, it is the current file that you are currently editing that will run, not some other files whose name is indicated here. So because I'm on current file, if I hit my run button, definitely it is this file that will run. So I'm going to hit my run button now, and let's see what goes. I'm going to hit my run button. I've already hit it, and let me see. The output is supposed to come out somewhere around here. Okay, it's there already. Look at it. Okay, welcome to NLS Tech. So that's it. So you have to adjust this place, because this is where your output will be displayed. So it's the same thing. And whenever you run your code in under your PyCharm, and you see something like process finished with exit code 0, then you will know that everything actually ran well. If it doesn't run well, you see something like -1 or some other numbers there, and you get some error code on red and all that here. Then you know that something is wrong with your code actually. So that's it for that. Then like I said, installing Anaconda does everything for you. You can run your PyCharm, you can run whatever, and also Anaconda has a base environment. Now there's something called an environment in Python, which we'll talk about much more later. So it has a base environment that it installs everything into it. As in, it has your Python, it has your data analysis software like your Pandas and your NumPy. It has a whole lot of things installed into it. So it makes life much more easier for you. But the problem is that you have to make sure that you have some level of system resources that can accommodate that particular software. Your RAM size, your hard drive size, you have an SSD hard drive and all that. So because it's resource intensive, so you make sure that you have things that it can make it run well and efficient in your system. So okay, in interpreted language, this is exactly what we just did, not quite long. You write and you run. That's all. Then for compiled languages, you write, you compile, and you run. So that is it. Then that takes us down to variables. What are variables? Variables are the building blocks of a program. Yeah, without variables, you can't really do much. Yeah, everything that you create, everything that you want to create somebody's name, you want to create an account statement, you want to create whatever thing that you want to do, these things are being stored in a variable. If you are collecting something from a particular database or from a particular from an API and all that, whatever data you're collecting from those sources will definitely be stored in a variable. There are containers where you store your values. There are containers where you store your values, and we have different types of values. Now, just a quick one. I'll be using my IPython environment. Like I said, it's still installed inside your Anaconda. If you can install Anaconda, you get everything in there, but I actually install them separately because I don't have much system resources and all that. So IPython 3, I think I should be right. Okay, yeah. So like I said, variables now. Variables, they are containers that you use in storing your values. Now, on this Python environment, this is the Python interpreter. This cursor is blinking, waiting for you to actually enter a command. You don't need to write your code in a particular file. No. Every code that you want to write in a file, you can easily write them here, and Python will automatically interpret it and give you the result, just like Jupyter Notebook we saw earlier. But this one is it's similar to it actually, right? It's almost the same thing. So let me write a very, okay, it's even in my cache, what I did just now. So let me print out this thing, and you see welcome to NLS Tech. It's there, so I don't have to run anything. Immediately I just write a particular command. It's like issuing a command. Immediately you issue the command and it goes voila, you're done. If you have an error in your code, it will. Let's say I decide to do something like this now without Okay, after this, okay, let me end here now. If I run the code, it will not run, and if I go again, it will not run, meaning that it's missing something. So I have to do something like, okay, let me close my parentheses and I'll go. Oh, there's an error. So I was actually waiting for this error on terminated string deleterial. So you can see that when there's an error in your code, it gives you automatically. You don't have to close your file, edit it, and all that. Like what I normally use this environment for, it's for testing a particular set of code. Let's say I have a very close code to write, but probably over 100 lines, and I have certain concept that I have to explain. Sorry, I have to write. I'll come here, test my code first of all before I go there to write the full code. So it's always good to actually come here to test a particular concept to see if it will work well. Then before you go into your source code proper, that's your IDE now or whatever text editor that you are using to write and get your results. So variables now. Variables are the building blocks of a program. Variables, they are the building blocks of a program. They are containers that stores our values. Now, if I write something like name is equal to, let's say, Henry, okay, and I hit my enter key. Name is a variable. It is a container that is storing the word Henry, and every variable has their own type. Every variable has their own type. This name you are seeing is currently a type of variable. It has they have their own data type. It's currently a type of variable called a string. This is a string variable. Do you know why it's a string? Because Henry is a string. A string is a collection of characters. It's a combination of different characters. So we have HENRY, 5 characters is making up this particular string. Now, you saw me earlier writing C++ code, right? Now, C++, things like C++, C, Java, and all that, C#, they are strongly typed languages. They are compiled language, strongly typed, in the sense that before you create any variable, you have to declare the type of variable that you are actually trying to create. Without you declaring, that is, you have to tell the compiler what you are doing. So I think in fact you are 100% in charge when you are writing in those languages. But in Python takes the context of the variable that you are currently storing in as the type of variable. The context of the value now that you're currently storing in the variable as a type of variable. If I decide to write something like, let's say, height is equal to let's say 5.6. 5.6 is not a string, it's a decimal number, right? Now 5.6 in the world of computer is a floating point number. Yeah, they call it float. So height will automatically be treated as a floating point variable, as a floating point data type, because the value I am storing inside of height is a floating point type of value. So when you are using height, you have to use it like you are storing a floating point. Now, if I come here now to say height equal to 5.7, sorry, 5.7 now, okay. Now, your variable takes the most recent value that you are assigning into there. If I check the value of height and I say print height, I'll get 5.7, no longer 5.6, because the most recent value I bounded to the variable is 5.7. So that is it. So if I have another variable like say age 50 now, what is 50? 50 is an integer. It's an integer. And age will have the properties and values of the properties and methods of an integer. That's what age will have. So age now in itself is an integer. Now we have different types of variables actually. So like I said, you can now look at what is written here. Values could come in the form of letters, strings, numbers, decimals, boolean, and all that. Okay, we saw decimals just now, which is actually floating points. Now numbers now, they are the integers we saw just now. Then boolean. Now boolean is either true or false. So if I write something like is red, I can say true, and is red is a Boolean variable because true is a Boolean type. It's a Boolean type of value. Now, how can you know the type of variable that you have created? Python has a unique way of checking it using something called type. If I say type name, look at what it will give to me. str means string. It means that it means that name is a string data type. It belongs to the string data type. That's it. What it means. It means if I say type now, let's say type age now. Okay, type age now. Okay, age is an integer. It means that age belongs to the integer data type. That's what it means. Now, the word type, and type. Whenever you see something like let's say type parentheses like this, it means that that thing is a function. So we won't talk about functions much more later. So type is a function, and every little thing in programming, every little thing you see on your screen now, on your code and all that, every name you create, whether it's like this type you are seeing, is type is the name of a function and all that. We used print just now. We used this print, another. We used age, is red, type, and all that. Now these things, they're all called tokens, and they're all called tokens now. Whether it's the name of a class or a method, properties or whatever. In as much as you are creating a name or using an inbuilt name, these things are called tokens. Now, variables operate on each other with the help of operators. Yeah, we have different types of operators that variables normally operate with. Okay, Python variables now. Okay, we have integers, floats, strings, and all that. These are examples of strings: hungry, computer, programming is an intense fun. These are types of strings. These are types of floats. And all that, different types of floats and all that. Then these are integers, which we are actually seeing. Then the operators I was talking about. Okay, naming and variables now. Yeah, variables. Yeah, you can use whatever thing that you like as a variable name. You saw me using isRed just now. True. Now it's not as if isRed is something that I memorized, or maybe it's in a book or something. No, it's not there. You can decide to write your own, like, is it red? Then you come here to say true. So it's the same thing. Whichever name that you are actually using as your variable name is allowed. So although there are certain reserved keywords that Python normally use to operate, it uses it for its internal operations so that it can help interpret your code and give you the right result. Those keywords, they are reserved. I think there should be more than 30. Yeah, they are reserved keywords for the language itself to actually use. Every language have their own keywords that are reserved for them. Now, this particular guy here, it's a variable. The age I'm writing here is a variable. The height is a variable. You can use any name as a variable. Now, this is my own thinking, my own thinking as of now. Tomorrow now, I might be writing a particular script and I will use completely different variables. So you can use whatever variables that you want for yourself. But the thing is, you have to make sure that you use a descriptive variable name that is self-documenting. Yeah, it's clearly stated here. Use descriptive variable names, and descriptive naming convention that are self-documenting. Self-documenting in the sense that they should depict the meaning of the value you are currently storing inside the variable. For example, you saw me writing age just now. Age is equal to 50. Now, based on what you can depict from the code I've written so far, it's an indication that I'm trying to write about someone whose name is Henry. The height is 5.7 and he is 50 years old. So it's descriptive in nature. You can easily understand it. It's better than doing something like let's say n equal to let's say n equal to, let's say, Rita. Then let's say the age now, I'll now put a equal to, let's say, 67. Are you getting it? It doesn't really make any sense. What does N stands for? Fine. At the instance of writing this particular code, you might know within yourself that yes, N is for name, A is for age and all that. But when you come back to your code, let's say in 2 months or 3 months time, trust me, you won't be able to remember what N stands for, because you didn't use names that will help you remember it. Now, we don't write code just for ourselves alone. We write code for other programmers to equally read and understand. So that's why we have to use names that are descriptive in nature. Then we have, outside the fact that you cannot use those reserved keywords that the language normally uses for its operations, you can not, there are certain naming conventions that you have to use, certain acceptable naming convention that you have to use. For example, now there are different types, so a lot of persons have come up with different types. We have the camel case and all that. This is the camel case, where you have to separate each word with by capitalizing the first letter of the next word. This particular guy here now, it's amount_spent. Now this guy used underscore now to separate these two words. So now when you are naming a variable, spaces are not allowed. It is forbidden to use spaces. I cannot come here now to say let's say I want to write age now. Maybe let's say I want to say, okay, Henry's age now. I'll say Henry age is equal to 50. If I hit enter, it will give me an error. Look at this, invalid syntax. Invalid syntax. It shows that spaces are not allowed when you are naming a variable. Then you either use an underscore, or Henry underscore age. This will work. Or Henry age now, capitalizing the first letter of every word that comprises of that particular variable. Now, there's a convention now that you might think, okay, some persons might say, okay, Henry dash age equal to 60. This one, yes, it might look correct because you are currently mixing up these two names, now Henry age with a dash. But the computer might see it as a negative sign, because operators and computers, they are similar to what we have in mathematics. Your addition is there, your multiplication is there, your subtraction is there, and all that. That is why it's not really encouraging. It's not advisable to use this dash. It is valid actually, but there are some. I don't think Python is even valid in Python. I seriously doubt. Okay, we're going to try it now. But I think in some other language it should be valid, but it's not really an encouraging concept to use. Yeah, I thought as much. It's not valid. Syntax error. Cannot assign to expression here. Maybe you mean equal to instead of this. No. We don't mean any of those things. Why it's not working is because he said you cannot assign to expression here. It's taking this Henry dash age as an expression. What is an expression? An expression is when you are using the operators now to manipulate two variables. I can have I minus j. Let's say I is a digit now and j is another digit. So I want to subtract the two of them. So I minus j is an expression. Now I can still say I minus j, it will still work. Now spaces between your operations, they are optional. It's your choice, whichever space you want to do. But when naming a particular variable, it is not allowed in any languages at all for you to actually use a space to name a variable. So what Python is thinking this particular thing to be, he said cannot assign expression here. It means that you are trying to assign 60 to this expression. That's what you're trying to do. You're trying to assign 60 to this expression. So it's taking Henry dash age as Henry minus age, which will not work. So another, okay, now, okay, look at this one. Okay, this one now, okay, has a car. It's true. Yeah, like I said, it's under the acceptable naming convention, but there are some languages, like I said, Python is not, does not accept this particular naming convention. Now, there are some languages that will definitely accept it. Yeah, don't really care about it, but it will come to hurt you when let's say for example, I have car now. I have car as let's say I have car as equal to Mercedes. Okay, then A is something, right? A is already 67, right? Okay. Now, if I now decide to say has a car is equal to true, it means that I'm trying to subtract car, which is Mercedes, from 67. It doesn't really make any sense now. And I'm trying to store this true into storing true into an expression that's completely wrong and absurd. Then another bad naming convention again, it's beginning a variable name with a number. It is not allowed. It is not allowed at all. So we can give it a try. Let me see. Yeah. Oh, okay, now exactly. It's not allowed. Invalid decimal literal. So you cannot start a variable name with a number. It's not allowed. Then the last one is a little bit tricky here. This last one you're seeing is a little bit tricky. Now this thing is allowed, but it's under the invalid variable names. There's a reason why it is under the invalid variable names. But let's see, it is allowed. If I say fruits is equal to banana, yeah, it is allowed. It's not as if it's not allowed. But it's advantage of this particular underscore fruit to Python. You can use it in other languages and also, but it is a peculiar name to Python. Python takes any variable names that starts with an underscore as a private name. Now, underscore, when something starts with an underscore in Python, it means a special meaning actually. Now, there's a concept in programming called OOP, object-oriented programming, and we have things like classes. In this particular concept, we have classes, we have methods, and we have properties and attributes. Now, and we have attribute modifiers and method modifiers. When you are trying to hide certain things. Now, when you are doing it in Python, using an underscore to start a variable when you are creating a class, indicates that you want that particular variable now to be private to that class. There is something called private and public, right? Okay, but it is not always advisable to start your variable with an underscore. It doesn't really make much sense in Python. Now, okay, look at the Python keywords I was talking about now. I think there should be about 31. These, all of them, or maybe I'm missing something there. I can't tell. But if you go to the Python website, python.org, yeah, you can get a lot of things there. These are the Python keywords: and, as, at, break, class, continue, def, del, and all that. These things, they are forbidden. You cannot use them as variable names. They are completely out of touch because they are used by the language itself to actually carry out whatever operation that you're trying to do. And also, you can use these things when you're writing your code. Definitely, these are things that you use in writing your code so that the language can understand what you're trying to do and help you print out execute your code. Now, there's something that's missing here. For example, I can add the print statement. I think the print is not here, right? Okay. Now, print is there. Print is a special keyword in Python. We'll be using print. We'll be using print before now. Even type, there's a type now. I can come here now to say print. equal to 5, it will give me an error. Okay, print. It's the bet. It's not really a good idea to actually use print as a keyword, in the sense that even if it's not giving me an error, but if I want to print out something or I want to use it somewhere else, it's my mistake. It might mistake this particular print as its own inbuilt variable, as its own input keyword. So it is always a good idea to avoid using these guys as a variable name. If I decide to use else now, else equal to 6, syntax error. So it's forbidden. If I decide to use break now equal to, let's say I say computer, it's a syntax error. Sometimes it might not really give you a syntax error, but when you are using it in your code, when you are using it properly to write your own program, you might have conflicting names and conflicting ideology that you are trying to make Python to actually do for you, to actually execute, and you're going to get errors, and you might not be able to track it down to your variable type that you have used, your variable name that you have used. You might not be able to track it down to it. So it's always a good idea to completely avoid these things. So that's it. Then another thing again to avoid is this: when you are creating your file name, I told you that when you are using your PyCharm, yeah, you can create file names now from this particular variable from your projects now. Yeah, now when you are creating file names, do not use Python keywords as your file name. It is also forbidden. I cannot, let's say I want to create a file now. Okay, I'll right click, I'll go to new and go to Python file. I cannot say class. It doesn't really make any sense. Now, even if it works, but trust me, you're going to get errors along the line, because when you are trying to compile this code, you're trying to run the code now, it's going to give you errors that you might not really be able to trace down to the fact that you are using a Python keyword as a file name. You will debug and debug and debug and debug. You will never get the error. So that's why it's always good to avoid using these things. Variable assignments. Yes, variables are not explicitly declared in Python, unlike in other strongly typed languages. Like I earlier said, we don't explicitly type declare variables in Python. No, it's not explicitly declared. For example, let's go back to our C++ code now, right? Okay, let me see. I need to exit this environment. Then let me check something. Okay, now vim hello.cpp. Now let's say I'm writing a C++ code and I want to write somebody's, let's say I want to say okay, somebody's age. Now I can do something like age equal to 50. I cannot just write age equal to 50 like that. It doesn't happen. It will give me a complete error. Let me save the file now and compile it. Hello.cpp. That's it. You can see it's even telling me that age was not declared in this scope. But in Python, variables are not explicitly declared. But in other languages, some other language, not or PHP, no, you don't declare variables there and all that. The same thing like Python, it assumes the context of the variable, or the value that you are trying to store in the variable as the variable type. So, but in this case, you have to explicitly declare it. You have to tell the compiler that, hey, age is an integer. If you are storing a string, tell it that age is a string. So, for me to debug this particular code now, I have to go back to my source code and I'll put an int there. When I put an int there, go back and let me compile now. Now, you see that it works well. I've been able to tell the compiler that age is an integer. But let me go back and write it in my Python code now. Okay, pi. Okay, let me say age equal to 50. Let me go then Python 3 hello.py. Everything still works. I don't have to declare anything. Python already knows. So that's why Python is a little bit more higher than the traditional compiled languages. Yeah, it's a little bit more higher, and it does a lot of things for us implicitly on our behalf, so that we can really focus on the logic of our code. Now, the types of variables depends on the kind of values that is assigned to it. Yeah, person, herring, and all that. So this guy takes like fruit. Now, fruit is the data type of fruit is a string. This one is an integer. This is a float and all that. So that is how it is. Then operators in Python, just like mathematics now, addition, subtraction, division, assignment. This is an assignment operator. You have to understand this one very, very well. Now, there's something called associativity. That is the way you associate a particular operator. Associativity. Now, I think when we were in school doing mathematics, let me go back to my IPython terminal. If they say x equal to 5, our thinking was, okay, x is equal to 5. We always think from left to right. This is the mistake that you will make if you continue to think like that in the world of programming. The associativity of this assignment operator is from right to left. It's from right to left. So your thinking should be, okay, I'm taking this 5 now and I'm storing it inside of x. I'm taking this 5 and I'm storing it inside of x. So x is the container that is actually holding this particular 5 value. So that should be your thinking. Then equal to, yeah, these are logical operators actually. This is equal to, not equal to. This is multiplication, exponential, integer division, modulus, and all that. Now, we've been using the assignment operator. If I say x equal to 5 and I decide to check the value of x, now x, I'll get 5. You understand? Now, even name. Okay, we have not declared name currently. I can say name is equal to Henry, right? Okay, name will give me name. Now, a lot of persons might be confused that why am I not using a print statement, right? Why am I not using a print statement? It's as simple as this. What you are seeing here, this is input number 2, which is x, and this is output number 2. So in this out now, you are seeing the line number, indicating that this line number is an output of the inputs that you entered. This is 4, indicating that this particular line is an output of your input you entered on this number 4 command line. So using a print statement or not, it will always work. Now, the reason why it's working is because I am working directly on my Python interpreter. If I was working on a script now, let's say my PyCharm now, or PyCharm, yeah, it will not work. It will not work because in that case, I'll have to use the print statement. I cannot just go and write it. Let me go back to my PyCharm now and say, let's say I have name is equal to Frank, right? Okay, I cannot just come here to say name. It will not work. It will not work. It will not give me Frank. For me to actually output something when working on my PyCharm, I must use the print statement. It is a compound must. You cannot just write. The reason why it's working here, like I said, the reason why it's working here is because I am working directly on the interpreter. Yeah, on the IPython interpreter. So it already knows what age means now. It already understands the value of age, and so that's why it is outputting the value here. So that is how it is. Don't forget, when you are working on your PyCharm, you must always use the print statement. If I run this code now, you will see Frank will definitely come out. Let me run the code so that you will see it very well. Look at it, Frank is out. So without me using this particular print statement, it will not come out. Let me write name now after giving it a value, and let me run to see what will happen. There's no Frank, so you must use a print statement for this particular name to be outputted. So that's it. Then okay, I was talking about the assignment operator just now, right? Okay, so that's it. So when you assign something, it goes and it stays there as the value of that particular variable. Then equal to, now equal to is a logical operator. Actually equal to, not equal to, then is it greater than? Oh, I won't miss out on a greater than. Yeah, there's greater than and less than and all that. Now the equal to, now I can write something like, say okay, I have name now, right? I can say, let's say name 2 is equal to Frank, right? Okay, if I do something like the name equal to name 2, it will give me a false. Do you know why? Because Henry and Frank, they are two different names. It will not work. It will definitely give me a false. So it's correct. If I go ahead to do something like this now, name not equal to Frank, then it will give me a true, because actually name 2 is not equal to name. So a name is not equal to name 2. It's correct now. So that's why it's giving me a true. That's giving me a true, because Henry and Frank, they are two different things. So if I say let's say I say I equal to 70, j is equal to 26, j is equal to I, is a false. They are not the same. If I change j now to 70 and I say j equal to I, it will give me a true. So because right now they are now equal to the multiplication. Yeah, it's our normal multiplication. I multiply by j, it gives me the answer, and so on. Then exponential, yeah, when you're trying to get the power of something. If I want to say, okay, what was my x? My x was 5 now, right? Let's say, okay, want 5 raised to the power 2 now, which is x exponential 2, and that will give me 25. So that is it. So double star is for exponential. Then integer division. Okay, now yes, our division and yes, our integer division. What the difference? Difference is that the integer division truncates the decimal part of your result. Here is it. If I say x divided by, okay, let me see what's I. Okay, I is 70. Okay, let's say I divided by let's say 7, no, let's say 6. Okay, it will give me 11.66666. That's it, right? Okay, this is our normal division, which is actually correct. But if you want an integer division, it means that you want to truncate the decimal part of things. It's not be I double forward slash and 6, enter. It will give me 11. That's integer division. I just want only the integer parts. So that's it for that. Then this other one is a modulus operator. It's very simple, where you have to look for the remainder of something. So if I say, let's say I modulus 6 now, what's the remainder? The remainder is 4. That's it. Oh, that's the modulus operator. Simple and clear. Then there is this greater than less than, that is actually not here. If I say I greater than 80, it's false, because what's the value of I is 70, so it's false. So these are all logical operators still. So if I say I is less than 80, it will give me a true, because I is 70, which is truly less than 80. So that's it for that. Then okay, the print statements now. That takes us to our first function that we'll be using, which I have been using before now, the print statement. So I particularize this particular guy here now, this particular concept, which is meant for Python 2.x. Now, this is not the only difference between Python 2 and Python 3. I think there are other differences actually, but it used to be only the print statement. But as time progresses, they were adding newer features and changing a lot of things from the usual Python 2.x, and we now have a lot of differences between Python 2 and Python 3. Yeah. So for your best interest, it's better to use Python 3.0 and above. So this is the print statement, our first function. Now, what's a function to start with? A function is simply something that has a name and a parenthesis. That's this open parenthesis and this closed parenthesis. That's a function. Whether you have something inside or not, it's nobody's business. So long as you have an open and closed parenthesis, it is a function. That's a function. So then we have other types of the print statements. Now you can alter it a little bit, adding other parameters to it and all that. Like these are our end and sep and all that. Now what is the meaning of this end and sep? End means how you end this print statement. Sep means the separator between the variables. That's what it means. That's the difference. End is how you end the print statement, while sep is the separator between the two, the various variables that you have printed within this print statement. For example, let us particularize something like that now. I think what is name? Okay, name is Harry, right? Have we done age? Okay, let's say age is 50, right? Okay, then okay, let's just use this to now to particularize our end and our separator. I'm going to start with the separator part of things. If I want to print something like my name is, let's say I am Henry and I am 50 years old, I can do something like print I am Henry, and then I am what, 50. I am 50 years old, right? Sep is equal to, okay, no, let's go first. Let's say if it will actually work. Okay, it worked. I'm Henry, I'm 50 years old, right? Okay. Now, by default, when you print out different variables, or I can go ahead to say print name, age, it will give me Henry 50, right? Okay. Now, by default, when you print a series of variables, it separates these variables with a space. Look at the space in between. That is the default way in which Python was programmed, in which this particular function, this print function, was programmed. That is the default way. Now, you can change things because it depends on the output that you want to print out. A lot of things can happen where you have to change the way a function behaves and the way it works. So let us now change it in such a way that we'll now write Henry 50 or something. Let's do something like, okay, name Henry, age 50. Let's do something like that now and print out certain things out. Okay, let's just particularize this guy now. Name, let me see, comma, age, right, comma, sep equal to, let me do something like this now. Okay, now, yeah, let me see, okay, yeah, so I think this should work, yeah. Let me hit my enter key. So that's it. So the separator is now this column and a space, no longer the normal space default. So it's now column and a space. Now, if I remove this particular space, and I hit my enter key, there will be no more space there, just Henry. So meaning that I am obliterating the default space that was being used, that was programmed into this particular function to be used to separate my variables. I'm now using my column. That is why you are no longer seeing this space there. This space wasn't because of the fact that it was programmed to use the space. So no, it didn't come along with the default space. No, it came along with this my space I included there. So when I removed the space and it was gone. So that's it. So separator gives you the flexibility to actually separate your variables that you're printing out with different types of tokens and make sure that what you are separating it out is a string. It is within 2 double quotes or a single quote, whichever one. It could be 2 double quotes or single quote. Now, when you are saying 2 double quotes and single quotes, as far as Python is concerned, they are the same thing. I can say name 2 now is equal to Frank. It's the same thing. Watch. Let me check the type of name now. It's still a string. So whether it's single or double quotes, it's the same thing. But just make sure that when you are using this separator, it has to be in double quotes. Yeah, a string now. Then another one again is this, using the end. Now, Python by default, this print statement by default is normally printed out on a single line. Are you getting it? It is normally printed out on a single line. That is, it puts a new line by default on itself. Watch, if I say print welcome and I hit my enter key, look at the new line that is currently placed there. After welcome, there's a new line here. Now watch, let us go back to, let's remain here. I think this should be a very good way to understand it. This is the print statement, right? By default, print adds a new line to the end of the statement. I didn't ask it to come to the next line, to actually come to the next line. Yeah, right, exactly. But by default, it comes to the next line by itself. Now, watch. If I do something like this now, print welcome. Let me see. I think this should then end equal to. I'm not ending it with a new line now. I'm just doing something like this now. And there's no new line. What you are seeing here in programming is a void. When you see two double quotes without anything inside, after the double quote, the next thing is a double quote. It means that it's a void. There is nothing inside. It's an empty string, completely empty, is void. So I'll come here now. I'll hit my enter key. You can see that this space that was placed here is now gone. So by default, the print statement adds a new line to every line that you print out. It has a new line, but when you now come here to alter it a little bit by using your end option to null it, then it will no longer print that extra new line that it was designed to print. Now, putting a null value here is not the only option that you have at your disposal. You can go ahead and do something like, I can put a dash here now. Watch what will happen now. That's it, a dash. That is, after welcome, a dash. So it prints out this guy now, meaning that at the end of this welcome, there was a new line here. There was a new line at the end of this particular welcome. In between this welcome and this double quote, in between these two, this E and this double quotes now, there was a new line there that you cannot really see, that Python automatically imputes into it. So that's how it goes. Now, let me go back to my PyCharm to experiment something so as you can get a full concept of what I'm trying to say. This is Python. Welcome to NLStech. Okay, now if I say something like this now, programming is fun, right? Okay. Now I go here. I come here now to say print data structures and algorithms. Right? Okay. Now data structure and algorithm is hard. Now, how do I go about it? Now, let me print out these things so I can see the output. Yeah. Now, here's the output. Welcome to NLStech. That's line number 1. Programming is fun. Line number 2. Data structure and algorithms is hard. Line number 3, right? Okay. But if I don't want these things on separate lines, probably I want, let's say, the first 2 on one line and the last one on its own line. I'll have to do something like this now. I'll come here to put a full stop now. Now, I don't want this particular programming is fun to continue on the next line. I'll put a comma here and put end equal to, that's it. It means that the new character, the new line that Python normally puts, that new line there, and that is put, I don't want it there anymore. I want to end with a null character. I want to end with a null character. So that's it for that. If I run this code now, you see how to run. Let me see. Let me run it to you. So that's it. Welcome to NLStech. Full stop. I think it full stop. Then programming is from continues from there. I ended this line with a null character. Then because I didn't touch this particular one, this one by default ended this line with a null character. Sorry, with a new line. That is why this other print statement continued from the next line. So that's it for that. Then if I wanted something like this, now let's say I don't want a null character, I want a space to be there now. You see what will happen now. It means that after this decimal place, I'll have a space before my P. Let me run it now, you see. So that's it, you can see it. After this full stop, there's a space here before the P. So I'm ending this line with a space. That is why you are seeing a space here. That is how it is. And also, you don't have to press your Control S when you are working with PyCharm. You don't have to press your Control S. No, by default, when you type in your code and you run it, it has already been saved for you. You don't have to press any Control S or whatever to keep track of your stuff and all that. So yeah, we have different versions of the print statement. Yeah, this is the print hello format variable and all that. These are another versions of the format method now and all that. Now there is something in programming that is called, now we've talked about functions, right? We've talked about functions and keywords and variables and a lot of other things. There's something called methods. Now methods are functions and functions, they are similar. They do the same thing, they mean the same thing. But the difference is this: it depends on the environment in which they are currently existing, the environment that they are existing. Now, the print statement now collects a string, and this particular variation of the print statement uses formats. For example, now, let me practice this thing for you to see. This format you are seeing here, this dot, there's a dot here. This format you are seeing here is actually what we call a method of this particular string. These double quotes you are seeing, definitely we know that is a string, right? Okay. Now this format you are seeing here is a method of a string. These dots you are seeing here, it is used to call every method, not only of a string, but of a particular data type. Now, if I see print now, what will I use now? What will I use? Should I use this same guy? Okay, let me say hello. Okay, hello. Hello. Okay. Comma. Oh no, sorry. Format, right? Let me say name, right? Okay. Hello, Henry, right? Now, the Henry that you are seeing here is coming from this particular name. The Henry you are seeing here is coming from this particular name. Now, this name is a variable that is this what you are seeing here actually. This call braces you are seeing here is a placeholder to actually use in storing any value of a variable that you put in this particular place. And the number of variable that you put in this format method, in this format function, I said something earlier that anything you see with a name and an open and close parenthesis, this format has an open and close parenthesis, right? So it's a function. It's a function in itself. So this particular format function now can contain as many variables inside that you want. Actually, they are called format parameters. Later we'll talk about it. Now, it can contain as many variables as you want, depending on how many call braces you have within your string. Let me print out the name and age all together. I can say print hello this. Okay, no, let me say I am this. Oh, full stop. I am this years old, right? Okay, but format. name and age, right? Okay, very good. Now, the reason why I'm using name and age here is because within this um, print statement, within this string, I'm using two call braces, this one and this one. I'm using two here. If I have three here, it means that I have three variables inside here. Now, if you have two call braces here, they must be matching. If I have two call braces here and I have just one variable name here, it will output an error for me. If I have one here, I have two here, it will output an error for me still. So they must be matching. Number of variables you have inside the format statement must be matching with this particular guy here. And if I execute this particular command, it will replace these call braces with these variable values there. So that's it for that. Now you can index these guys. So you can index these guys. That is, you can put them in order, beginning from 0. Now, before I go further, there's one thing you must put at the back of your mind, which we will actually do later. Computers start printing from 0. That is normal. Computers start printing from 0. Whether you are doing Python, it's C++, or Java, whichever one you are doing, they start printing from 0. So if I want to rewrite this particular print statement using the indexes of these call braces, I can put a 0 here and I'll put a 1 here. Now, this 0 and 1, it's indicative of the print, of the index that these variables are actually standing for. Now, from this particular format function, this name has an index of 0. This age has an index of 1. Like I said, the computer starts counting from 0. So if I hit my enter key, it will give me the same thing. I'm hearing I am 50 years old. Now, let me switch it a little bit so that you will get the check very well. If I decide to say something like print, I am this years old, right? And okay, wait. Let's say my name is this, right? Okay, format, name, age. Okay. Now, let me put a 0 here, and let me put my 1 here. Then I will hit my enter key. Oh, it said there's an error. Okay. There's an error here. Let me rewrite it again. There's a syntax error. Okay. Okay. I think I'm good to go now. Okay, yeah. So I am Henry years old. My name is 50. Doesn't make sense. I switched the statements now. I am 0 years old now. I am Henry years old. My name is 1 now. It is because I'm using the indexes. The first index here is name. The second index here is age, which is 0 and 1. 0 and 1. So for me to actually print a statement that makes sense, that looks similar to this, or rather a statement that makes more sense, I have to switch the indexes. I'll come in now to put my 0, and I'll come in now to put my 1, meaning that this 1, it's for the name, and this 0, it's for this 0 is for the age, for the name, and this 1 is for the age, because it's 0 and 1. So I will hit my enter key, and that's it. I'm 50 years old. My name is Henry. So that is how it is. Then there's a third version of the print statement now, which is using the F keyword, using the F letter now. Now it's not a keyword now; it's just a letter for the print function. Now, what does the F letter do? F means format. Now, it's similar to this particular format, but it's much more explicitly defined, or rather used. Instead of using indexes, it is much more explicitly used than what you are seeing here. If I have to write exactly what I wrote here using the F letter, I have to do something like print F. My name is name. Okay, I am 8 years old, right? It's even there. So I think it's name and age, right? I'll hit my enter key. That's it. My name is Henry. I'm 50 years old. So you can see that I don't have to put the indexes. I don't have to put the format. It's the same format stuff. If you look at it very well, F means format. That's normal. So that I'm not using indexes again. I'm using the real values now. Sorry, the real variables now. That's exactly what I'm using, and they will be replaced by their value. And make sure that they are in curly braces. It is very, very, very important. So that's it. But the typecasting now or conversion, yeah, exactly. This is another very important aspect of programming. How do you typecast or how do you type convert? Now you can typecast certain things into other things. You can typecast a data type now, a variable type now, into other variable types. Yes, but you cannot typecast all types of values now, all types of variables now into other types of variables. Yeah, there are some that doesn't really make sense now. Like this one now, integer cat. It's like I'm converting my cat now. I'm converting this my cat now into an integer. How on earth do you think it's gonna work? What do you think it's ever gonna give to you? Logically, it is wrong. Mathematically, it is wrong. Somehow, anyhow you want to think about it, there is no way it's gonna work. Now, convert integer a into an convert letter a now into an integer. This one itself in itself is also wrong. Now, I know a lot of persons might be thinking that a belongs to some group of hexadecimals and all that. Yes, that is correct. But as far as programming is concerned, as far as Python is concerned, a is an ordinary letter. But this one will work. You see this 5 you are seeing here. 5 is not an integer. It is a string because it is in between our double quotes. It is in between our double quotes. So 5 is a string. If it was standing alone, then it's an integer. So Python can work with this. Now you can convert this particular 5 now into an integer because this 5 we are seeing here is what we call an integer string. It is an integer string. Now let's say I have I equal to 5 now. Yeah, let me use 5. Now let me check the type of I now. What's I now? I is a string. It is not an integer, it's a string, but it is an integer string. Things like this can be converted. Yes, I can say I can say INTI and Viola. I have 5. So 5 is now an integer, but I still remains a string. You can see it still remains a string. For me to actually change the value of I, it means that I have to say I equal to int I. So I am typecasting my I. Then the result of this typecasting, I am storing it inside this my I. That's exactly what I'm doing. So meaning that I performed 2 operations here. I typecasted and at the same time I stored. So I'll hit my enter key, and when I check the value of I now, it's now 5. If I check type I, I'll get an int. So that is how it is. But if I try to typecast let's say dog, for example, now it's an error. Invalid literal for int with base 10. It's not possible. It's an invalid literal. It means that particular string I am passing as an argument inside this particular int is not working. It's invalid. So accepting inputs. Yes, we talked about output now using the print statement, right? Now accepting inputs. By default, users inputs are strings. This is where typecasting comes to play again. Users inputs are strings by default. Users inputs are strings. So if I do something like let's say let me see okay, now let me check something. Okay, user input, right? Okay, user input is equal to input. Okay, now this particular input now, it's a function currently. Like I said, whenever you see a name and this parenthesis now open and close, it is a function. So what does this function do? It allows us to ask our users now of our software, of our program, to key in a particular value, and whatever value that this particular input is collecting, it collects it as a string. Even if I type 7 here and I hit my enter key, this 7 is not an integer, it is a string. Now after collecting it, it stores it inside this user input. This user input is a variable, Now it is a variable. It is not as if you have to be using inside inputs. No, it's my own name I just gave my variable. Like I earlier said, variables can be anything. I can decide to say UI equal to input, and I'll write 7 there. So what's the value of UI now? UI is now 7. You can see that UI is a string. It's in between single quotes. So UI is a string. It's not an integer. Even if 7 that I typed in here is an integer, it's an indication that the input function collects strings. It doesn't collect integer or floats. Now, if I decide to say, let's say height is equal to input, and this input now, I decide to write, let's say 5.8, right? I hit enter. What's the type of height now? It's still a string. Height is 5.8. It's still a string. So whatever value that are inputting that are collecting using this particular input function, whatever value you are collecting using this input function, that value is always a string. Now, in most cases, when we collect values now from users, we don't always want strings. We don't always want strings. Some cases, yeah, you want, depending on the program that you're trying to write, you will have to look for a way of casting these things into the variable type that you actually want. Now, that is where typecasting comes to play now. What we initially treated. Typecasting, yes. You have to convert these things into the variable type or the data type that you actually want so that you can work with it. If I have to add a particular value to 5.8 now, or maybe I want to add 5 to 7 now, it will not work. I guess it will not work because it's not giving me the 12. It will give me something else. If I say UI plus 5 now, error. It is an error because you cannot combine a string and an integer. So I'll come back to this particular error code that we've got in here. It's a type error. It can only concatenate string, not int to string, right? Okay, very good. Then how do we now type convert it now? How do we type convert it now? You can type convert it in 2 ways, either on the fly or while you have finished storing it. For example, now let's say you have UI now equal to input, right? I write 90, right? Okay, this is 90, right? UI, let me check the UI. Now, UI is 90. Now I can type convert it after assignment. I can see UI is equal to int UI, and I'll hit my enter key. So what's now UI now? It's now 90. It's now an integer. It is no longer a string like the way it used to be. So you can either do it after you have collected the value from the user, or you can do it on the fly. If I want to do it on the fly now, I'll do something like UI is equal to int input. Okay, that's it. Then I'll hit my enter key. Then I'll write, let's say 67 now. What is UI now? UI is what? UI 67 is an integer because I type converted this particular integer on the fly. Immediately this input accepted this 67. There was this integer conversion type waiting for it. So after acceptance, this integer function now did its work by casting it into an integer, and that was it. So let's say, for example, I decided to say age is equal to what? Input. How old are you? Right? I'll get it. How old are you? And I'll get something like 45. And that's it. So what's age now? Age is 45. So, but right now, age is age is a string. You can see the single quotes surrounding the 45 now. Age is a string. It is not an integer. So I'll have to do something like, I have to typecast it definitely now. So age is equal to what? Int age. And that's it. So when I write my age, I have my 45 there. So that's it for that. Then, okay. that's it for that. Then exactly what we have said now. But if you are collecting users' name, because name is always in string, there's no point typecasting your name. No, you leave it as a string. That's why I say it depends on the program that you're writing. You can decide to, like this particular statement here, you are collecting someone's weight, so you need to typecast it on the fly, or you can do it after collecting the weight, whichever one. They all will work. So long as you casted it before using it in that particular code. Then when I was trying to combine something just now, I had a type error called it said can only concatenate string, not int to string. That's can only concatenate string to string. That's string to string. It can only combine string to string. That is very, very correct. Now, there's a concept called concatenation. It's just a fancy word for combine. There's no much big deal. There's just a fancy word for combine. Now, how do you concatenate in Python? Different languages have different ways of concatenation. Some use full stop, some use addition sign and all that. But Python uses addition signs. Now, the concept of using a particular operator, we talked about operator earlier, using as in we have different operators, subtraction, multiplication, division, and all that. Now, the concept of using an operator or a function name or a method or whatever, the concept of using a particular operator, a function name, in more than one instances, or using it to achieve a particular different goals now, is called overloading. So like the plus now, I can add 8 plus 9 here, it will give me 17. That is, the plus sign is used for addition. At the same time, it is used for concatenation. That is, it is used to combine. So it means that we are overloading the plus operator. So I can do something like, what's my UI? My UI is 67, right? If I say UI plus 8 now, it will work. Okay. If I say UI plus 5 now, it will not work, because 5 is actually a string. 5 is actually a string, so it's not work. So now how do I make it work? Now it means that if I have to combine these two, let's say I want to combine UI and 5. Now I want to add 5, and 5 is a string. I have to say UI plus int 5, and it will work 72, because I actually typecasted this particular guy. We normally use this concept now during our print statements. If I decide to print certain things, like let's say what was the name? The name is Henry, right? What was the age? Age is 45. Okay, I can say print. My name is. Then I'll put a plus sign here. I'll put plus again. Then comma. I am plus sh plus. The code is still in my system. The this automatic completion intelligence is still there. Now, okay, now look at what I did there. Say my name is what? Name. I am this years old. Now, if you look at this name, look at what's happened here. String age, because I was combining this string I am and this part and this part of my print statement, they are all strings, and I'm using the plus operator here. Now this is an example of overloading, operator overloading. So I'm using the plus operator now that I normally use to add different numbers and floating point numbers together. I'm using the plus operator now to combine my string now, to concatenate my string and my age now. It will not work because age is an integer, so I must typecast it. I must typecast it here before it will work. So that's why you are seeing it. Now, if you look at this name now, name, I'm not typecasting it because name by default is a string. So you can combine a string and a string. Like what look at the error that was given to us on this place. Now it said can only concatenate string to string, not what? An integer. So because I can only concatenate strings together, that is why I am not using a typecasting here. I'm not casting this particular name now to string or to whatever, because name in itself is already a string. So my name is this, I am this years old. So if I run this particular code now, it will work, right? But if I go back now and I decide to say, okay, let me remove this guy here, and it's an error, can only concatenate string to string. So that's it. So this is another variation of the print statement. You can use this one and it will still work. You can use, so whichever one you want to use, but you don't normally concatenate only when you are trying to print. No, there are scenarios where you have to combine strings and floats and all that. Now it's not only integers. So if you're trying to combine strings and floats, for example, now I can say print, I can say name has plus has a height of plus, okay, string height. Right now, remember height was, height is a float. Yeah, height was a float, 5.8. So I have to still convert it to a string. You must always convert it to a string as far as you are trying to concatenate it with a string. So that's it about that. Then okay, now I guess that concludes this particular section of Python, which is the introductory section. The problem set here is this. It said write a program to calculate how old a person will be in 8 years time given his or her present age. Okay, how do we do this now? It's quite simple. It's a very simple program. It's just to add age to the present age of someone, and you'll get your answer. But we're going to do it in a much more interactive way by asking the person for his name and age, then we'll do the conversion, then we'll do the printout. Let's go to our Python, to our Jupyter, to our PyCharm to write the code. Now, I'm going to do something here. You see this entire code, I'm highlighting it currently with my mouse, and I'm pressing my control and forward slash on the keyboard. Hold your control and you press your forward slash. It will give you this entire thing there. It will gray out the 3 statements. Now, do you know what happened here? This is what we call comments in Python. Now, what are comments? Comments are little descriptions you add to your code to actually explain what each particular statement is doing, and also what that particular program itself is doing. So in addition to writing descriptive variable names that are self-documenting, it's always a good idea to always comment your code. So in this first piece of program that we're going to be writing, I am going to be commenting my code. Now, I have commented out this thing. The reason why I commented out these 3 lines of code is because I don't want it to reflect on my output, because if I don't comment it out, it will reflect here. I'll keep on saying welcome to NS Tech, programming is fun, data structure and algorithm is difficult, and all that. Every time I run this particular code, it will always be there. Or better still, let's create a new file to see how it works. So I'll come to this place, I'll right click, I'll go to my new, and I'll go to my Python file. I'll call that file calculate age. Then I will hit my enter key. So I have created a new file now called calculate age instead of using my previous tests file.py. So I'll create a new file called calculate age now. So let us now solve that particular problem set now. The problem set says that we should calculate how old a person will be in 8 years time given his or her present age. It's a very simple program to write, but it will help you to understand how to work with variables and do a lot of things. Now, I can do something like say, where do we start from now? Okay, like I said, we're going to ask the person for his or her inputs, the name and the age. Then we will now have to add it to the age so that we can calculate the person's age in 8 years time. So first thing first, I'll be writing this particular code using comments. So the first comment I'll write is prompt the user for his or her name. So I'll go back, I'll now write something like name is equal to input. What is your name? Right? Okay. Then prompt the user for his or her age. Age is equal to what? Input. How old are you? Right? Okay. Now, remember that age, we need an integer in age. Oh. Don't forget that. So I cannot just write inputs like that. My input will collect the age very well, but it will store it in this particular variable as a string. So it doesn't really make much sense. So it's better to typecast it now, to convert it now. Int now. I'm converting it into an integer. So that's it. So then now we've done the 2 lines. Now we've written lines that will collect the person's name and age. So our next line will be to now do the main thing now, to calculate the person's age in 8 years time. So I'll now go here to say add it to the current age of the user. Now this comment I'm writing is completely personal. It depends. You must not write exactly the same comment. It's just for your remembrance, just for your memory, in case you come back to this particular code, say in 2 or 3 weeks time now, so you can remember it. Now this particular code that I'm writing, it's a very simple code. It is obvious. You can write it anyhow you want to write it. These questions that you are asking the user to actually key in the answers, it's even a descriptive way to actually understand the code in weeks or something. So it's even documenting itself. So you don't have to comment this code. But the reason why I'm commenting it is to show you how to comment codes and the importance of it. But if you are writing, let's say, 100 lines of code, or 200 lines of code, 300 lines of code, or even 1,000 lines of code, you're going to have different files, working with different modules, working with different libraries across different types of sources, probably from a database source or API or something. You will have to comment your code because you cannot have 100 or let's say 1,000 lines of code that you're working without adding comments. Definitely in a week's time or 2 you are going to get confused totally. So our next point of code now is to add age to the current age of the user. So I'll come here now to say age is equal to what? Age plus 8. So that's it. Now once again, I am doing 2 things here. First thing, I am adding I'm adding 8 now to my current age, and I am storing it as age into age. Now I am adding 8 to my current age, and I'm storing it as age. So I am replacing the old value of age. First of all, now this adding of 8 to 8, it doesn't change the value of age. It does not. It doesn't. What changes it is this assignment operator, by assigning it back to age. So this is where the magic happens. It has happened, and the next thing now is to print out something that will tell the person that in this year's time, this is what you will be. So I can go ahead to say print in 8 years time. Then I will do something like this. This will be this years old. Adjacent. Sometimes you might have to say, okay, you don't want to do this. You can say new age. you can just write new age. At least writing new age, probably I think it's much more understand using new age as your new variable. It's an indication that you are trying to get the new age of the person, or you can come here to write future age, whichever one. It depends on what you feel comfortable with yourself. So in 8 years time, this guy will be this years old. So I'm going to put a dot here, format. Then I'll write something like name, comma, future age, and that is it. So let us run this code. Now when you are using your PyCharm now to run your code, sometimes you get to see this particular exclamation mark here and all that. It's telling you that there are 2 weak warnings. Now you can do without them and it will be correct. Like this one now is giving you some kind of warnings here, 1 year, and probably it's telling you that the space in between here is too much. Fine, you can go ahead to run your code. Now you can never have too much spaces in your code. Yeah, you can never have too much spaces in your code. Now it's not really it doesn't affect your code. But Python is a language that actually it enforces you to use indentation. By the time we start writing our own custom functions and working with external function, you realize that indentation is very, very, very important in Python. In fact, it was built with the language as a result of history of seeing a lot of clumsy and so many complicated code from C and C++ and Java programmers. So that's why this thing was built into it, and it's a very, very nice idea. So if you like, you can take away this particular space, or you can leave it, whichever one. You can see that after taking this thing away, the 1 is now changed to 1. I still have 1 weak warning, so you can do away with whatever weak warning that you have. But when you are seeing a red sign there, it means that there's a bug in your code. If I go ahead to do something like that, if I remove this double quote, you can see that look at this exclamation mark. It's red. It said 13 errors. So it means that there's an error in my code. It might not necessarily be 13 errors. Maybe one particular error now. Okay, now like this double quote now I just removed. It resulted in 13 errors. So it doesn't really mean that you have to look for 13 lines to get to go and debug it and correct the errors. No, it may be just one particular point, like our case here where I just removed this particular double quotes and it's telling me 13 errors. So if I run this code, it will give me an error. And if you look at the file itself, it's giving me a red underscore here, telling me that there's an error on this code. Probably definitely a syntax error, not a logical error. Now I'm going back there to do it again. Now it's gone, the red line is gone and all that, just this one. So with a weak one, you can still run your code and it will run fine. So we're going to run this code now using our run command. Okay, it's asking me now, what is your name now? I will say Frank. How old are you now? I will say 17, and I'll hit my enter key. So it's telling me that in 8 years time, Frank will be 25 years old, and that is it. So that draws the conclusion of this particular section of Python introduction. So this is second program for you to go and do. This particular problem set was taken from the textbook, How to Think Like a Computer Scientist. Yeah, it's a very good way to practice how to use variables actually, because you have different types of variables that you have to input values in them. It calculates the final amount of a compound interest. This is the mathematical equation, so you can go ahead to practice it. This sign you are seeing here, this caret sign, is it's raised to power. So this is a formula, and this particular entity, it's an exponential to this formula. So that's it about that. So I hope you had a nice time listening to my lectures. And one more thing before I go, please do make sure you like, share, and subscribe, and so that a lot of persons can have access to this particular video and also be beneficiary to a cool introductory lecture in Python. Have a nice day. Bye bye.